Hello, everyone. My name is Lucie Castel. I am a French textile engineer. I graduated from ANSET, France in 2021, and I am specialized in technical textiles. I worked on the unit 5.1 with Anne Perwels, which is a teacher in ANSET and PhD in material sciences, specialized on surfaces. Since 15 years, she created a new thematic in the laboratory of ANSET, which concerns sustainable textiles, eco-design, and circular economy in textiles. I will now share my screen with you to present to you the unit 5.1, which is about yarns and non-woven fabric production in circular economy. In this unit, we will first see the different yarn spinning production processes. Then we will talk about how to handle fiber blends. We will then see the different environmental impacts, then how to use the recycled and waste fibers. And then we will go through the non-woven production processes and how to use recycled fibers. So first of all, the yarn spinning processes. We can divide the yarns into two big families, the staple yarns and the continuous or filament yarns. The staple yarns are made of fibers. The fibers are between 10 millimeters and 500 millimeters long. When the fibers are between 10 millimeters and 60 millimeters, we say that they are short staple fibers. When they are between 60 millimeters and 500 millimeters, they are long staple fibers. For example, the cotton fibers are short staple fibers, and the wool fibers are long staple fibers. The systems used to spin the fibers is different when it's short or long staple fibers. For the short one, we will use the corded and combed systems, and for the long fibers, we will use the woolen and worsted systems. The appearance of the yarns will differ, as you can see on the different figures. The continuous or filament yarns are made of filaments of infinite length. We say it's infinite length because the diameter of the filament is way smaller than the length, so we consider it is infinite. It is of infinite length. We will first start with the filament yarn spinning, so how to go from polymers to multifilament and possibly to yarn. The different operations are as follows. First, we have some granulates of polymers, and we will convert them from solid state to fluid state. Once they are on fluid state, we will extrude them to get monofilaments or multifilaments. We will draw the filaments to orient the polymer in the direction of the yarn, and we will convert, if needed, the filaments. Converting means cutting the filaments in little pieces. The polymers can be, for example, polyester, viscose, polyamide. They are synthetic or artificial materials. There are different spinning methods. We can find the dry spinning, the wet spinning, the melt spinning, or the gel spinning. The only difference will be the steps 2 and 3. So the conversion from solid to fluid state and the extrusion of monofilaments or multifilaments. The 3 other steps will stay the same, but the steps 2 and 3 will change. For example, in melt spinning, we will melt the polymers, while in the wet spinning, we will dissolve them. Now, how to go from a fiber to yarn, which is the staple fiber spinning. The operations are different, and first we open the bale, because when fibers arrive in the companies and the industries, they are in bales, so we need to open them. Then we can mix or blend the different fibers. We can mix different colors. We can blend different nature of cotton, different cotton of different origins. Then we clean and we separate the different fibers. We align them, we draw, and we spin. Here again, there are different spinning methods. We can find the ring spun yarns, the rotor spun yarns, the twistless yarns, the wrap spun yarns, or the friction spun yarns. The only step that will change is the last one, the spinning step. The ring spun yarn is said to be conventional, while the others are non-conventional, but it's only vocabulary. How to handle fiber blends. Most of our clothes are made of blends. Most of the time we have polyester, cotton, elastan, for example, clothes. So how to make those blends? It depends on the fibers we use. If we make a blend of synthetic and synthetic fibers, then we can cut the filaments to obtain staple fibers and then spin them, but it's not mandatory. So we can convert the filaments or not. When we have a blend of synthetic fibers and natural fiber, if we use the conventional method, so the ring spinning, the materials are intimately blended, and it's not possible to mix fibers of such different lengths in conventional processes. So we need to cut the synthetic fibers to have the same order of length as the natural fibers with which they are blended. If we use the non-conventional methods, the materials are not intimately blended. The filaments can be used as core in the yarn or as binding, so it's not necessary to cut the filament. And then if we blend a natural fiber with another natural fibers, then they can have lengths really different. For example, linen and cotton. The linen is the longest natural fiber, while the cotton is a very short fiber. So we need to recut the longest fibers to make them with the shortest one. However, when we mix cotton with cotton, for example, it's not necessary to recut the fibers. The important information here is to remember that to mix two fibers together, it's necessary to have the same order of length. What about the environmental impacts of yarn production? Spinning can represent up to 1 out of 5 of a cotton garment global environmental burden. And more than 75% of the greenhouse gas production of spinning processes comes from energy consumption. The energy consumption is directly related to the thickness of the yarn. The thinner the yarn, the more energy it consumes. The different sources of environmental impacts for yarn production are firstly the energy use. That can be energy used for processes or for humidification systems. We have the consumables used, such as the chemicals, the packaging materials, and how they are disposed. We also have the amount of fiber waste created and how it is disposed. Sometimes the fiber waste can be reinserted into a spinning process, as we will see later. But some very short fibers cannot be reinserted and they can be used as flock or as padding insulation material. We also have, lastly, the amount of dust and loss created. We will now see how to use recycled fibers. If we want to use recycled polymers, they can be used as virgin ones through dry, wet, melt spinning. We can find some information in the unit 4.3 about the technologies for textile recycling. We will see how to use recycled polymers. However, the output material may have lost mechanical properties depending on the process used. When we want to use recycled fibers in the staple yarn, then it's necessary to know that the recycled fibers are shorter than virgin ones. It is therefore necessary to mix the recycled fibers with virgin ones to ensure the mechanical properties of the yarn. We can spin recycled fibers through rotor spinning, friction spinning, or ring spinning. And most recycled yarns are coarse count because it's really difficult to make thin and middle count yarn because of the non-uniformity of fiber length, unopened fibers, small yarn pieces, other imperfections in the recycled fibers. We will go through now the rotor spinning, the friction spinning, and the ring spinning processes to see how to use recycled fibers. So first, the conventional method is the ring spinning. In this process, the drawing is carried out on the rolling mill system, and the twisting is conferred to the yarn by a traveler, which moves on the ring. The winding on the bobbin is done thanks to the delay that the traveler takes in relation to the spindle speed and the rise and fall of the carriage on which the ring is placed. This process contributes to a stronger yarn and is the most often used method for cotton yarn spinning. The fiber orientation in this process is good, which helps with the spinning of short recycled fibers. The applications of this process is mainly clothing or towels. The second process is the rotor spinning, also called open ends process. The principle of this process is similar to the production of a cotton candy. A sliver of fibers is fed into the spinner by a stream of air. The fibers come into contact with a rotating camber roll, which creates a thin stream of fibers. This thin stream of fibers is deposited in the V-shaped groove on the outside edge of the rotor. And as the rotor spins rapidly, it imparts twist to the fibers. The fibers are incorporated into the rapidly rotating open end of a previously formed yarn that extends out of the delivery tube. So you have fibers here in this V-shaped groove. It rotates, and here you have an open end which will lick in a way the groove and will and then the fibers will be incorporated in this open end. Rotor spinning is cheaper than ring spinning, but the strength of the rotor spun yarn is lower than the ring spun yarns. The applications are mainly carpets, towels, sheeting, furnishing, or clothing. The last process is friction spinning. In this process, a sliver is fed to an opening roller where the fibers are individualized. Thanks to an airflow, these fibers are brought between two drums, which rotate in the same direction. This detail is really important because the fact that they rotate in the same direction will bring torsion to the yarn. And between these two rollers is a core filament. The fibers will be wrapped around the filament to form a yarn. The friction spun yarns have a poor orientation, and they are not as strong as ring spun yarns, but they have a very good appearance. They are mostly used in softening filters, mop, carpet underlay, or terry towels. It's possible to use recycled fibers in yarns, but not all blends are possible. As I said before, when there are too many short fibers, then the yarn will not have good mechanical properties and won't be usable. There is a machine provider, which is called Riter, which produce recycling systems for rotor and ring spinning. On their website, they have a table with possible blends on Ritter systems. As you can see, for rotor spinning, it is possible to use up to 87.5% of pre-consumer recycled material. For ring spinning, it is possible to use up to 60% of pre-consumer or post-consumer recycled material. For rotor spinning, it's only 75% of post-consumer recycled material. This difference can be explained by the fact that the post-consumer recycled material is damaged by usage, so it will be more fragile than the pre-consumer recycled material. We can find the difference between the post-consumer and the pre-consumer material in the unit 5.3, which is about technologies for textile recycling. On the website of Ritter, they also propose a quality classification. According to Ritter, to have a very good yarn, the short fiber content should be 45% maximum. If we have more than 78%, the yarn will be of poor quality. We will go now through non-woven production processes. The two main steps to produce a non-woven are web forming and web bonding. The different processes of web forming are dry lead, spun melt, wet lead, and others like electrospinning. And for web bonding, the different processes can be mechanical, thermal, or chemical. The choice of process is determined by the fiber used and the final application of the product. We will go through each processes of web forming and web bonding together. The first process for web forming is dry lead. In dry lead, natural or synthetic polymer can be used alone or in blends. We can divide the dry lead processes in two categories, the corded webs and the air-led webs. The corded webs are produced with a cord, and they are produced from short staple fibers or long staple fibers. They are mostly used in geotextiles, building, roofing. The air-led webs are produced by suspending relatively short fibers in air and transporting this mixture to a continuous permeable conveyor where the fibers are deposited to form a web. And this web is mostly used in automotive as a soundproofing or as thermal insulation. The second web forming process is spun melt. In spun melt, the web is formed from continuous filaments that are produced by extrusion process. The production process is fully integrated, enabling polymer chip to be made into fabric into one continuous operation. Here again, we can divide the spun melt processes into two categories, the spun bond webs and the melt blown webs. The spun bond webs contain coarser fibers and have a great tensile strength. They are mostly used in filtration, medical gowns, geotextiles, or wipes. And the melt blown processes use high velocity hot hair strings that impinge on the filaments as they are extruded, involving attenuation of the filaments. They have a smaller diameter filaments and superior filtration properties. They are mostly used in filtration, oil absorbents, protective masks, blood filters. The third processes are wet lead webs. The web is produced using technologies that originated from the paper making process, in which the fibers are first suspended in water. But in this process, whereas paper is normally produced from short and fine fibers of cellulosic composition, in wet lead nonwovens, the fibers can be longer, and can be composed of many different natural, high-performance, synthetic, or inorganic materials. The applications are mainly tea bags, air and liquid filters, surgical clothing, drapes, insulation. We will go now through the bonding processes, and the first mechanical process is the needle punching. In most nonwoven, the fibers are arranged in a planar fashion within the structure. Very few are oriented in a thickness direction, and in the needle punching process, some needles are oscillated through the web and they are reorient groups of fibers into the interior of the structure in the thickness direction to link and to bond the web. The main applications are automotive, furnishing, geotextiles, building. The next mechanical bonding process are hydroentanglement and stitch bonding. In hydroentanglement, high-velocity water jets entangle fibers in the web. They displace, they're reoriented to increase frictional resistance to slippage and strength of the fabric. The applications of hydroentanglement are synthetic leathers, wipes, thermal protection, geotextiles, coating substrates. The other process is stitch bonding, and according to its name, it's just stitching or knitting the fibers in fibrous web together. And the applications are wipes, thermal insulation, filtration, absorption. The other process is thermal bonding, and this process is suitable for fibrous webs containing fibers made from thermoplastic polymers. The web is thermally bonded by fusing the thermoplastic components to the surrounding fibrous materials, and it can be done through wire bonding, calendar bonding, ultrasonic bonding, or microwave, infrared, or laser heating. The main applications are wipes, filtration, geotextiles, insulations, tea bags. And the last bonding process is chemical bonding. Air binders consisting of polymer latex adhesives in the form of emulsions, dispersions, or solutions are deposited onto fiber surfaces in the web and dried and cured to form a cross-linked film that bonds adjacent fibers together. Sometimes nonwovens are solvent bonded, which means fibers are treated with a solvent specific for the constituent polymer in order to produce bonding in the web. And the main application of this bonding process is wipes and sponges. How to use recycled material into a nonwoven? The advantage of nonwovens is they accept very short fibers, which is an advantage for fiber recycling. And it's possible to recycle fiber blends and non-textile materials into nonwovens. Natural synthetic fiber blends can be an advantage for thermal bonding, for example, because synthetic fibers will bond the web. The easiest recycling method would be dry-lead followed by needle punching, because very short fibers are accepted in dry-lead process with no water, no need for polymers, no need to heat, no water, no chemicals in the needle punching process. But the choice of process will depend on the application and the desired properties of the final material. Here you can find some references about the yarn and nonwoven fabric production if you want to go further in the subject. I hope you enjoyed this unit. Thank you for your attention.